Hello friends, welcome to Bindu Dhadwal chemistry lessons. Today we'll be doing dioxygen and ozone in the P block elements. So dioxygen is prepared by the thermal decomposition of oxygen rich compounds like potassium permanganate, potassium chlorate, potassium nitrate, etc. For example, potassium permanganate on heating will decompose into potassium manganate, manganese dioxide and oxygen. Potassium chlorate will form potassium chloride and oxygen. Potassium chlorate is used in the laboratory preparation of dioxygen, where it's heated in the presence of manganese dioxide at 420 Kelvin to give dioxygen. We can also prepare dioxygen by decomposing various peroxides, dioxides and higher oxides. For example, from hydrogen peroxide we can decompose and produce oxygen dioxygen by catalysts such as finely divided manganese dioxide. On large scale, dioxygen can be prepared by liquefaction of air, where air is liquefied and then fractional distillation is done. Liquid nitrogen distills out first, leaving behind liquid oxygen. We can also prepare it from water by carrying electrolysis of acidified or alkaline water. When current is passed, it decomposes it into its ions, H plus ions and hydroxide ions. At anode, the negatively charged hydroxide ions go and lose electrons, forming dioxygen gas, whereas at cathode the hydrogen ions take up electrons to form hydrogen gas. Properties of dioxygen: it is a colorless, tasteless and odorless gas. It's slightly soluble in water. Its solubility is to the extent of 3.08 centimeter cube in 100 centimeter cube of water at 293 Kelvin. It has three stable isotopes, O16, 17 and 18. So despite having even number of electrons, it is paramagnetic in nature because according to molecular orbital theory, the anti-bonding molecular orbitals contain one electron each, giving rise to its paramagnetic nature. It can react with various metals and non-metals, forming oxides. For example, with calcium it forms basic oxide, calcium oxide. With aluminium, aluminium oxide is formed, which is amphoteric. With phosphorus, acidic oxide is formed. It also reacts with sulfides of metals, forming sulfur dioxide, which is an acidic oxide. Then compounds such as methane burn in oxygen, producing carbon dioxide and water, and reaction is exothermic in nature. For dioxide is oxidized by dioxygen in presence of vanadium pentoxide, forming sulfur trioxide, which forms the basis of manufacture of sulfuric acid in the contacts process. Hydrogen chloride can also be oxidized in presence of copper chloride to form chlorine and water. Dioxygen is widely used, for example, in respiration and combustion. Oxygen cylinders widely used in hospitals by sea divers and mountaineers. Liquid oxygen is used as an oxidizer in rockets for fuels. The next compound is ozone. Ozone acts as a thick blanket outside our atmosphere, which protects us from harmful UV radiations. In the atmosphere, ozone is formed by the decomposition of dioxygen with UV radiations, which results in a combination of dioxygen and oxygen atom to form ozone. But in the laboratory, we can also produce ozone. When slow dry stream of oxygen is passed through a silent electric discharge in a special apparatus called ozonizers. Ozonizers can be Siemens ozonizer or Brody's ozonizer. The oxygen gets converted to ozone. Reaction is endothermic. 142.7 kilojoule of energy is absorbed. Ozone may decompose back to oxygen if direct electric discharge is used, so silent is needed. Properties of ozone: it's a pale blue gas, has pungent odor with boiling point 385 Kelvin and melting point 24 Kelvin. It's 1.5 times heavier than air. Its density is 24 grams per centimeter cube, which is 1.5 times heavier than normal air, whose density is 14.4. It is slightly soluble in water, more soluble in organic solvents like turpentine oil, benzene, carbon disulfide, etc. It liquefies to deep blue liquid at 161.2 Kelvin and solidifies to black violet solid at 80.6 Kelvin. Ozone is thermodynamically unstable and breaks by liberating huge energy, mildly explosive, and it acts as a strong oxidizing agent as it gives nascent oxygen. Ozone decomposes to give molecular oxygen and nascent oxygen. This nascent oxygen can oxidize various compounds. For example, lead sulfide plus ozone forms lead sulfate plus oxygen. In addition, it can oxidize various other compounds like zinc sulfide, copper sulfide, cadmium sulfide to sulfates, HCl to chlorine. Ozone, it also oxidizes nitrites to nitrates, potassium iodide to iodine, ferrous salts to ferric salts. It can react with alkenes in presence of carbon tetrachloride to form ozonides, and it oxidizes potassium ferrocyanide to ferricyanide, potassium manganate to permanganate, and may oxidize different non-metals, metalloids also. Quantitatively measure or estimate ozone, we use its reaction with potassium iodide solution, which is buffered with borate buffers. It liberates iodine when reacts with the ozone, and this iodine can be titrated with standard sodium thiosulfate. The amount of iodine ascertained gives us the amount of ozone present. So reaction is iodide plus ozone in presence of water will form iodine plus oxygen plus hydroxide ions. In the atmosphere, nitric oxide is released from the jets, from the exhaust pipes of jet aeroplanes. This nitric oxide decomposes ozone into oxygen and is responsible for depletion of ozone layer, causing ozone holes. A big reason for depletion of ozone layers is also the use of chlorofluorocarbons, which releases chlorine atom, which can deplete the ozone layer. Structure of ozone. Ozone has a bent structure with a bond angle of 116.80 and an equivalent bond length, oxygen-oxygen bond length of 127.8 picometer. This can be understood if we draw two canonical structures for ozone, one having a coordinate bond and a double bond, and the other reversing the positions of double and coordinate bonds. So the actual structure is an average of the two structures and is called resonance hybrid. Uses of ozone. It is used to purify air in crowded places such as cinema hall, underground restaurants and tunnels. It is also used as a germicide, disinfectant, and for sterilizing water. Ozone is used as a strong oxidizing agent in manufacture of potassium permanganate. It is used as a bleaching agent to bleach ivory, flour and starch.